Alright, so we're taking 3 points and we want to try to fit a quadratic model to it. If I only had 2 points, okay, you guys know what a parabola looks like, but if I only had 2 points, there are actually an infinite number of parabolas that could go through any 2 points. Alright, I could have this parabola here, I could have this one here, I could have a real tall one like that.
Thanks.
Okay, I could have this one right there. You guys get the picture. There's an infinite number of them. However, if I throw a third point into there, there's only one possible parabola that can go through all 3 of those points. Okay? Now, this doesn't just work for parabolas, although that's going to be our primary application. The idea is this: when you're given any kind of a polynomial model, or even if it's not a polynomial, okay? If you're given any kind of a model in a certain number of points, you can use those points to help you write a system of equations and then solve it in order to get a final answer, okay, and get what the equation of the entire model is. And the reason why that's helpful is because then once you know the entire model, you can find other points. Alright, so let's say you are, you're tracking a population growth, and you know populations grow exponentially. Alright, well, exponential functions, a b to the x equals y. You have 2 different variables, so if you get 2 points there, you could actually find the model there that would show your growth. Okay, if it was a continuous growth one, you would have a e to the rt. Okay. The amount at time t, here's our function, amount at time t equals a times e to the rt. Again, you only have 2 variables really here, a and r, our rate and our starting amount. Okay, and believe it or not, you guys actually did this earlier in the year to some extent. We didn't really present it as solving a system of equations, but that's really what you were doing. Okay? But anyways, we're going to look at specifically solving quadratic models, okay? And here's the scenario we're given. If we know 3 points, we're going to find a quadratic model for this situation. Alright, suppose a ball is thrown into the air and its height h is measured t seconds after it's thrown. So find h of t if we're given the following data.
Bless you.
Thanks. I was going to sneeze. Alright, so we've got a camera or something set up, and after we throw it, 1 second later we take a picture and we can tell its height is 15 feet, and then 2 seconds after we're at 38 feet, or sorry, 3 seconds after we're at 38 feet, 4 seconds after we're at 30 feet, and we want to fit this to this model here, okay? This h of t equals at squared plus bt equals c. Okay, so here's what we're going to do. We actually know what t and h of t are 3 times throughout the flight of the ball. So what we're going to do is we're going to plug in 1 for t and 15 for h. That's going to give us one of our equations. Okay? And if you look here, if I plug in 1 for t, I get a times 1 squared is a, plus b times 1 is b plus c, and that equals 15. If I plug in my second point, 3 squared is 9, 3 the first is 3, so I have 9a plus 3b plus c equals my height, 38. And then 16a plus 4b plus c comes because I have 4 seconds, so 4 squared is 16. okay, plus 4b plus c equals my height 30. Alright, and you can tell here, at some point in here we must have hit the peak because we're on our way down now. Okay? Yes?
What's your A and B situation?
The A and B and C are the coefficients and the constant in our height model. Okay, so if we wanted to use this and then figure out what the height was after 5 seconds or after 3 seconds, or to find out when it actually hit the ground, we could then, once we do A, B, and C, we'd have an actual model to work with. Okay? And really, that's the only new part to this application. The rest is getting your matrix and solving it. Okay? So, what would my augmented matrix for this system be?
1, 1, 15.
Ah, you got it. Good. 1, 1, 1, 15. Remember, the constants have to go in the last column, even though they're on the left in this case. All right.
Wait, how did they just give you all that information on the side, or were you supposed to figure out that it's like 16a plus?
Yeah, we just figured it out because we plugged in 4 for t. So we got 16a, 4b, and c, and then we plugged in h for the height.
Well, we get the equation, right? At the top, the equation that's circled.
Yeah, you'd be given a model to fit it too. And it may not be a quadratic, it may be something else, but the process here will be the same. Okay? So 9, 3, 1, 38, 16, 4, 1, and 30. Okay? Now, we're going to run out of time to actually solve this. Okay? In fact, we're about out now. Let me real fast though show you. This will be a way you can check your answers, but also it'll help us get an answer here. All right? Watch this. I've got our calculator here, and second matrix, if you go over to A, we're going to put in a 3 by 4 matrix. Hold on real quick. We'll be done in just a sec. 1, 1, 1, 15, 9, 3, 1, 38, 16, 4, 1, and 30. Please sit down so people can see. All right? I hit quit, and then watch this. Matrix, math. We go down here, and you'll see RREF. I hit enter. I go back to matrix, and I select the matrix A I just got, and there's my answer. A is negative 6.5, B is 27.5. That's how you can check all your answers.
Mr. Hickson,
All right.
Mr. Hickson.